So in this video, we are going to discuss some very important properties of center of mass frame, very interesting properties. And by the end of this video, you will be able to solve all center of mass questions, all standard questions just in one line. So you don't need to write so many equations and all. Just in one line, you will be able to solve the question, right? So let us see. So first I have listed down all important properties, which I am going to use for that one line solution. So first property is the net force on the system is always zero in center of mass frame, right? So let us quickly understand the logic also. This equation we know F net external is equal to total mass of the system into acceleration of center of mass. Now, if you are in CM frame, then acceleration of center of mass will be zero, right? Why? Because if you're moving with the same acceleration as center of mass, then with respect to you, center of mass will be stationary. So with respect to you, acceleration of center of mass will be zero. So if acceleration of center of mass is zero with respect to you, because you are also moving with the same acceleration with CM, then this term becomes zero, right? So if this is zero, then left-hand side will also become zero. So let us understand this from a very simple example of a spring block system. Suppose there is one mass m here, 2m, force applied on 2m, 4f force is applied, on m, f force is applied. So let us see when we go in CM frame, then is this true or not, correct? So in CM frame, what we have to do first, find the acceleration of center of mass, because there is a net external force on the system. That is how much? 3f this side, right? 4f minus f, 3f this side, total mass of the system. I'm using this formula again. That is f by m, correct? So if this is f by m, then in CM frame, now CM frame is non-inertial frame. So when you are in CM frame, so let me write here, CM is now moving with an acceleration of f by frame, f by m. So when you are moving with f by m, then with respect to you, pseudo force of, what is pseudo force? Pseudo force is equal to minus m a naught, right? Mass of the body, acceleration of the inertial frame, right? Non-inertial frame. So here, acceleration of non-inertial frame is how much? F by m, mass is m. So pseudo force, this red color I have highlighted. This was the force originally applied, this one, and red color is the pseudo force, right? So what is the total force on m mass now? 2f, correct? Now we don't, when you are doing this question in exam, you don't need to calculate the force on 2m. You know from this property that force will be 2f in this direction, right? So that is how you can keep saving small some seconds in every questions, and you end up having extra time to solve extra questions. Okay, so here in this question, we are verifying this. So let us go ahead and solve for this also. This is mass 2m, right? So what is pseudo force? 2m into A naught. A naught is, let me write here, 2m into A naught is what? F by m. So what is pseudo force then? 2f, right? Opposite, because the inertial, non-inertial frame has the acceleration in this direction. So pseudo force will be opposite. Now see, 2f is the pseudo force, 4f was the force applied. 4f minus 2f becomes 2f in this direction, right? That is what we were thinking, that this has to be that way only. If on m mass 2f force is acting in this direction, then on 2m mass also 2f force should be acting in opposite direction. That is what this means, right? I hope everyone has understood. So that is what I've written here. We can see that net force on m and 2m is 2f in opposite direction. So in exam, if you calculate net force on this once, then you don't need to calculate on this. Directly, if you're getting 2f here, apply 2f here, solve the question. Okay, so let's see the next property now. So next one is that force on one block in two block system is reduced mass into relative acceleration. So just now what we have proved, that if suppose you have a system and if you're in CM frame, then net force will be zero. So system will look like this. Suppose this is M1, this is M2. I've taken two block system. Then on this force will be F, on this force will be F this way, right? Because you are in CM frame, it has to be, net force has to be zero. Now this value of F is equal to reduced mass M1, M2, M1 plus M2 into a relative for two block system, right? So this is basically, you can write this directly from the logic of reduced mass, or you can do this normally also from definitions and arrive to this. I have left that part. Okay, try doing by yourself. But this I'm going to use in another, in some other cases also. So next one, again, very interesting. You might not have seen this before. Work done by pseudo forces in CM frame is always zero. Let us see, very Simple and quick proof. Suppose power delivered is equal to what on all particles, F dot V, right? What is F? F on F is pseudo force, right? On ith particle will be minus mi into a, because pseudo force is minus m e naught dot vi. Now, if you take a is constant, right? You're in, what is a? A here is the acceleration of non-inertial frame. So if with respect to this person, pseudo force dot vi, this is the power generated by pseudo force. On ith particle, if we add all such particles, I'm going to get total power. So A I have taken outside because it's going to be constant for all the particles. It is the acceleration of non-inertial frame, which is constant. And then you get sigma mi vi. Now, what is sigma mi vi? Sigma mi vi is the momentum of the system, right? Ith particle and then summation momentum of the system in CM frame, because velocity is in CM frame. You are in CM frame. Velocity is relative to CM frame. So momentum in CM frame is also zero always. CM is called zero momentum frame. That also I have written later, right? So sigma MIVI is equal to zero. That is why power delivered by pseudo forces in CM frame will always be zero. Again, a very interesting property. Now, next one, let us see. Kinetic energy of two block system in CM frame. Let us see that. So here, kinetic, this is the general formula of kinetic energy. I think you know this already. Kinetic energy of the system with respect to Earth is kinetic energy of the center of mass plus kinetic energy of the system with respect to center of mass, right? Now here, this formula is very important for us to know. Remember, kinetic energy of the system with respect to Cm for two body, again for two body systems, is half mu v relative square. So mu is again reduced mass, v relative is the relative velocity square, right? This kinetic energy of the system with respect to Cm. If you remember this formula, many questions, not here up to atomic and nuclear physics also, in atomic collisions also, you can use this formula and solve the questions directly. In nuclear physics also, when you have to find minimum kinetic energy to start a reaction, endothermic reaction, you can use this formula and find the answer directly in one line. You don't need to write 4 or 5 lines. Okay, so let's do this. Suppose again, two block system in CM frame, FF like this, net force has to be 0. Suppose this displaces by ds1, this displaces by ds2, m1 and m2. Then work done by force F will be, F is mu A relative, this we have just now did. W is equal to what? Mu A relative into, so what W will be equal to, let me write here, that will be equal to F ds1, right? Plus F ds2, correct? Work done. Now F dot ds here cos 0, here also cos 0. So F into ds1 plus ds2, which I am writing as ds relative displacement. Okay, so mu A relative into ds relative. Now A relative we can write as A, you can write as what? A you can write as v dv by ds. Now since A is relative acceleration, so velocity will be relative and displacement also will be relative. So if you write this here, v relative dv by ds, ds cancels. Integrate this. Sorry, I have to integrate this also. So if you integrate this, you get W is equal to half mu v relative square, right? Very, very important formula. Okay, so last and very, very important property is center of mass is a zero momentum frame. So if you are in center of mass frame, no matter how many particles are there, no matter system is discrete or continuous, it doesn't matter. Momentum of the system will always be zero. So center of mass is a zero momentum frame, because now why? Very simple logic. Momentum of the system is mass, total mass of the system into velocity of center of mass. So in CM frame, since velocity of center of mass will be zero, so again, the same logic, if you're moving, suppose CM is center of mass is moving with 2 meter per second, and you also start moving with 2 meter per second, then what do you observe the velocity of center of mass as? Zero, right? So that is what I've written as in CM frame, or whether CM frame is always which frame? The frame in which you are moving, but with the velocity of CM. So you start moving with the velocity of CM. This is CM. Then with respect to you, what is the velocity of CM? Zero, right? So velocity of CM is zero in CM frame. So momentum of the system is, again, if this is zero, that makes that also as zero. So momentum of any system in center of mass frame is zero. If you're solving a question, if you're in CM frame, and if you're doing some calculations, and if you see that momentum is not coming out to be zero, that means you have committed some mistake. You have to go back and check that. Okay, so there are small checks which will help you which will help you in analyzing whether in between of the question when you're solving and you are in between of the question, in between of the calculation, you're doing it correctly or not. So always, whenever you go to center of mass, check that momentum is 0 or not, right? So if you have missed a factor of 1 or 2, then very easily you can test that at that point itself. Okay, so now let us apply all this and see how do we solve the questions directly in one line. So first I have taken simple questions of collision, these questions are normally solved by writing one momentum equation and one coefficient of restitution equation. So I've taken this one, right? So this simple question, 2 kg mass, velocity is 4 meter per second, 4 kg mass moving with velocity of 1 meter per second. Both will collide, collision is head on and elastic equal to 1. Then what will be the velocities after impact? Now you are going to solve this question just in one line. So I have explained because I have to explain each and every step. So that is why I have written these many lines. But once you get the final, understand the final result, you can directly solve this question, right? That is my promise. Let us see. So with respect to CM now, center of mass velocity, you can find out 8. Sorry, just 1 second. Yeah. So let us find velocity of CM, that is m1 v1 plus m2 v2 divided by m1 plus m2, 2 meter. Go to CM frame, modify the velocities. Now CM, where is CM? CM is moving now right with 2 meter per second. So you start moving with 2 meter per second. With respect to, velocity will become 2, right? Give the velocity of CM in opposite direction 2, and this will become 1. Now, when we are solving this question, we have to first check we are in CM frame, right? So very small check here is that momentum has to be 0. 2 into 2, 4, this side, 4, this side, 0, right? So till here, I know that I have not committed any silly mistake. Okay, so after that now, so this is a very, very important step. If E equal to 1, and if it is head-on collision, then if it is coming with 2, it will always return with 2. If it is coming with 1, it will always return with 1. No matter what is happening, if it is head-on and there is no external impulse, momentum is conserved, then if collision is elastic, if it is coming with 2, it will always return with 2, right? Very simple logic. See, I'm writing the logic here. Just one line you will understand. Since center of mass frame is 0 momentum frame, so m1 v1 is equal to m2 v2. This will always be happening, right? So that means their velocities have a definite ratio, m2 by m1, correct? Right? And since E equal to 1, kinetic energy has to be conserved, right? Kinetic energy initial is equal to kinetic energy final. That is why they can only have these velocities. Why? Because if you say that, okay, this is not 2, why can't it be 4? So if I say that, okay, if this is 4, then this will also increase because they have to maintain a certain ratio. If both are increasing, that means what is going to happen if both are increasing? Kinetic energy in the system will increase, right? That is not allowed. So if this is 2, this is 1, then this will go back with 1. This will also go back with 1. This will always happen. Okay. So in elastic collision, particles will rebound with the same speed always if there is no external impulse, correct? Now, the moment you write this 2, 2, 1, 1, okay, and then go back and convert with respect to words. So this is 2, add this 2 and 2, 0, 3. This is the answer, 0 and 3, right? So since I had to explain, again, I'm repeating, I had to explain, I had to write so many steps, but you can just do it when you're solving an exam, you can do it directly in one line. Same example I've taken with E equal to half. Now same result. If it is head-on collision and if it is partially elastic, if it is coming with 2, it will coming with U, it will always go back with EU. The same thing for this also. These are the velocities in CM frame, right? So if this is in CM frame coming with 2, it will go back with E times 2, which is 1. This go back with half. That's it, done, right? Same logic. The same thing you can extend. The same explanation which I've given for E equal to 1, you can do this, right? Remember this very simple result, and you don't need to write momentum or anything. Final answer, convert back. This is 2, and then this becomes 1, and this is again half plus 2, 5 by 2, right? This is CM velocity. CM is going right with 2, convert back. Okay, no need to write momentum. So, and E, more lines you write, more chances for you to commit mistake, right? Okay, so here you might have noticed there are many questions in which you have to find loss of kinetic energy. Very easy. Kinetic energy initial, this I have written in CM frame, right? kinetic energy of two block system in CM frame is half mu V relative square. Initial. Final will be, if initially it is V relative, finally it will be E times V relative. Correct? This is the definition of coefficient of restitution. This is the loss of kinetic energy. But remember, I have written this in CM frame, right? But question was normally asked in earth frame. So I'm claiming that this is the change of kinetic energy in earth frame also, right? Let us see how. So this delta kinetic energy is in earth frame as well as in CM frame. Understand, very important logic. Now next questions, the normal other questions of conservation of momentum or center of mass, we are going to solve from this logic. So this is kinetic energy of the system with respect to earth, which is what? Kinetic energy of CM plus system over CM. This formula we know, we have done many times. Now, if kinetic energy of the system is same initial and final, if you see velocity of CM is same or momentum is same before initial and final, then kinetic energy of the system will be, CM will be same. So change in kinetic energy in earth frame will be equal to change in kinetic energy in CM frame. Very, very important result. Change in kinetic energy in earth frame, this is the kinetic energy of the system with respect to earth, will be equal to change in kinetic energy in CM frame, right? Since kinetic energy of CM is constant. Once you notice this, we can use this and solve the question just in one line. Let us see. So these are other standard questions. I have taken two of them. So question, you can read the question. This is mass m, small m. This is given velocity v. There is no friction. We have to find out what height will the disk rise after breaking off from the body m. The friction is assumed to be absent. Okay, so this answer is I have already given, and this is the normal solution. In this, there are four, they have skipped all the calculations and all, but still there are 4 lines. Once if you solve one paper, 5-6 lines minimum. Okay. So let us now see just in one line, how do we solve? See, this is this one line solution. What is this? Kinetic energy of the system with respect to Cm, half mm reduced mass into V square, right? Initial kinetic energy with respect to Cm I have written. You can see half reduced mass into V relative. V relative, this has 0 velocity, this has V. V relative becomes V, that is equal to change in potential energy of this, right? So you can, if you have understood everything till now, you can just solve this question in one line, right? Let me explain again how. See, finally, when this has moved to the max height, let us see what is going to happen. This has velocity v1, suppose. This will also have velocity v1, right? Momentum conservation. And if this is at max height, this will not have any vertical velocity component. So you can see initial momentum is mv, final momentum is initial and final momentum both are same, right? So velocity of center of mass initial and finally same. Now that means what? Velocity of center of mass is same initial and final. That means kinetic energy, change in kinetic energy of this system with respect to Earth is going to be change in kinetic energy with respect to Cm, right? The same logic here. See, change in kinetic energy of the system with respect to Earth will be the change in kinetic energy of the system with respect to Cm. So that is what I have done. Now here, kinetic energy initial with respect to Cm is this, half mu v relative square. Final, it's going to be 0, right? So that is equal to what? Change in kinetic energy is equal to potential energy, right? Done. This is done. Okay, so let us now the same thing I've explained here. K is equal to Cm plus system about Cm. Since this is very important, I wanted to repeat this. Delta Ke is equal to delta Ke system about Cm if kinetic energy of Cm is same initial and final, right? So this is initial, final, and energy conservation, right? So let us do one more question very quickly. There are all the questions you can do just in one line. So this question 2m and m, this is a ring, this is a point mass, system is released. If system is released, this what, and this is gravity is in downward direction. What will be the velocity of this, tension, radius of curvature, all kind of things are asked in the question. So the idea is, you know that if you find this velocity, all these things you can answer very easily. Now here again, see, when this becomes system becomes vertical, if this is v, this will be 2v, right? Initial momentum 0, final also 0. So you see that initial and final momentum is 0. Kinetic energy of the CM will be same. That means change in kinetic energy in earth frame is equal to change in kinetic energy in CM frame, right? So what is initial kinetic energy in CM frame? 0. Final kinetic energy is what? Half mu 2m and m, 2m by 3. V relative 2vv, 3v whole square is equal to potential energy. You got V directly just in one line, right? So after once you get V, you can find tension. with respect to the ring, this mass will be doing circular motion. So m times 3v whole square by L, right? And now, yeah, is there any pseudo force? No, there's no pseudo force. So this is T. Radius of curvature, again, you can find out very easily. The velocity of this v square by a perpendicular, acceleration in this direction is t minus mg by m, right? So that's it. So in this video, I focused on the standard and simple questions, how to solve. Now, if you like this video, please give a like to this and please subscribe to this channel and spread this video. So if you like this and this kind of content, if you realize that most of the places is not free, everyone is charging for this kind of content. So if you are sharing this video, if I get a very good response on this video, definitely I'm going to come up with next video very soon, where with these logics, I'm going to solve Erudove and Pathfinder questions just in 1 or 2 lines. Okay, fine. So that's it. Thank you very much for watching, for staying till the end. And please help me grow this channel. I'm planning to give a lot of good content absolutely for free. Okay, thank you. Thanks a lot. All the best.